Hello. Is my voice, am I audible?
Yes, sir.
Yeah, we'll just
It is
start
audible.
we will start in few minutes.
Hi, Girish.
Yes, Professor.
Yeah, so I am ready.
Yeah. Vasundhara, we can start.
Hi, good evening, everyone. Am I audible to you?
Yes, ma'am. Good evening, ma'am.
Good evening. I'm Vasundhara, the course instructor for this course, and I hope some of you might already know me through the live sessions. And today is our course orientation, and let me hand it over to Professor Janaki Raman.
Okay.
Sir, please.
Yeah, thank you, Vasundhara. So
Thank
I
you.
will share my screen. Okay. And please let me know if you are able to see my screen. Okay, not yet. Just wait.
Yes, sir, it's visible.
It's visible?
Sir.
Oh, and I'm loud and clear?
Yes, sir.
Okay, excellent. Good. So, okay. Let me know if you're able to see it now in full screen.
Yes, sir.
Yes, sir.
Okay, very good. Yeah, let me just clear up my screen. And okay, so first of all, welcome all of you to this.
Sir, audio is not clear.
Is it not clear?
No,
Sir,
it is clear.
it is clear for us, sir.
It's clear.
Yeah,
Clear, sir.
okay. Okay, so first of all, welcome one and all to this course on electronic systems. Okay, before we get the program of electronic systems, which itself is being launched by IIT Madras for the first time, and we are very excited to launch this program and have so many of you on board for the first offering itself. Okay, so today's agenda is primarily going to revolve around the course called Electronic Systems and Thinking, Thinking and Circuits actually. So it is sort of the first introduction to electronic circuits. Okay, and we have, I would say that this course has been designed like this for the first time by IIT, and is being offered to the the electronic system students. Okay, I don't know if there are other courses like this anywhere else.
Hello, sir. Sir,
Yes.
sir, audio is not clear.
No, I think it is clear for the others.
Yes, sir.
Yes,
Yeah,
sir, it is clear.
Yeah,
Maybe you
so-
have to check at your end,
Yes.
because for others are able to hear.
Okay. Yes. So, yeah. So my request is, if you have such a a request or complaint, please put it on the chat box. Okay, so that Girish can sort of look at it, take action, or he can interrupt me. Okay. If you have some questions, of course, you are free to sort of ask, regarding the presentation that is being made. But otherwise, any other queries, please put it on the chat box. Girish will take a look at it, and then he will interrupt me if it is needed. Okay. So thank you for your understanding. So so this course on electronic systems, thinking and circuits is what we are going to focus on today. The course is being taught by myself, Janaki Raman Veeraraghavan, my colleague, Professor Bobby George, and another colleague, Professor Aniruddhan. All of us are from the Department of Electrical Engineering at IIT Madras. Okay. I believe Professor Aniruddhan is on the call, and he will address you at a later point. Okay. So I am sure all of us have had a recent high or an experience of or excitement, with the Chandrayaan-3 actually landing on that to the southern pole of the moon, something that no other country has done till now. And fundamentally, if you look at it, there is a lot of course, there is rocket propulsion, there is aerodynamics, and a lot of things happening there. But electronic control is primarily what has, enabled the Chandrayaan-3 to happen, right? And even the earlier satellite launches, the whole communication from Earth to the, the lander and back, and the images and all that we are seeing is fundamentally, a culmination of the electronic systems technology that has simply taken off in the last couple of decades. Okay, and clearly it has a very deep impact and an influence on the modern society, and I would say even on the culture, right? The way people are talking to each other, the way people are interacting with each other. Electronic systems has a huge role to play in all of this today, right? So I would say that's the primary motivation for someone like you, a student, to even opt for electronic systems, right? So today there is artificial intelligence and data science and all that, and a lot of students are migrating there, but we are still happy that many of you are coming to these core areas. And I think you have made a great choice given the sort of technology and the challenges that electronic systems will address in the coming days. So why did we came up with this course, right? Electronic systems, thinking and circuits, right? So it so happens that, when we started thinking about the curriculum and things like that, we first of all took inspiration from the data science program. There is a course called computational thinking, right? Which is really not, it sort of very quickly covers all the aspects of computer science, but just at a top level, right? Just to tell you what kind of thinking is needed. Okay. So like that, we decided that it was actually possible for a student who's completed physics from class 12 and mathematics, of course, right? It was very possible for such a student to understand and appreciate most electronic gadgets to a first order, right? You might not be able to design it from scratch, but in order to understand it to a first order, this knowledge was more than sufficient. Okay. And essentially what we wanted to do in this course is sort of to provide an insight into the electronic systems encountered in day-to-day life. I think some of you might have watched the first couple of weeks, and I think you will completely agree with what I say here, right? So today's electronic systems, right, essentially revolve around sense, compute, and communicate. You're either sensing something, okay, be it with your camera, be it with your GPS, whatever it is, you're sensing something, then you're computing something, and eventually you're going to communicate with someone or something else, right? So these three blocks is something we wanted to outline in this course. Okay, so it will cover the basics of both analog and digital signal processing. Okay, now and I'll tell you more about this later. And the discussions will primarily focus on time domain analysis of signals. Okay, with very little introduction, or even the terminology of frequency domain you will not hear in this course. Okay, we have deliberately kept it that way because time domain analysis is something that you do in 12th standard through differential equations, and therefore we have decided to stick only to that. So what is what is different, by the way, right? The electronic systems thinking and circuits course is one thing, but if you just look at the electronic systems curriculum as opposed to the conventional curriculum, right, where you do a BTech or a BE in electronics and communication, what is the idea? It's always been that you do a lot of theory first, okay, and then you apply all of this later. So by the time you come to your third year, fourth year, that's when you do a project. Really, that's when you apply all that you have learned, and a lot of the concepts that have been taught in the past will sort of slowly dawn on you, and you will start understanding many of these concepts. Okay, and what we find is that because of this kind of an approach, what really happens is the student is not able to appreciate why a certain theory is being taught. Okay, so what we wanted to do in this program is actually to reverse the whole thing. Okay, we wanted to familiarize applications first, right? The theory will follow next. There's no problem, right? Like I said, to a first order, if you know what, in this picture, for example, there is a sound mixer. Okay, that's an audio mixer that you would have seen in live concerts. In 1 week, we actually analyze what this mixer does. How does it add signals? How do you build a circuit to do that? And so on, right? So the idea is you first familiarize yourself with the applications, okay? And saying, okay, if you want to build a sound mixer, you want to deal with a certain type of circuit that can do addition, that can do filtering, right? And you keep this in mind, and then you look at the circuit. The concept will stick much better, okay? And of course, without the theory, you cannot design anything. And therefore, the theory is very important. We are not trying to underplay the importance of theory in this course, in this curriculum. It is just that the theory can come a little later, okay? There can be a little lag. The theory can come next, and you will still be, and the advantage with this kind of an approach is when the theory actually is presented to you, you already know where that theory is being applied and why it is being applied. Okay, so with this kind of an approach, we believe that students will be able to appreciate, okay, electronic systems much better. And of course, the other thing is, electronic systems is sort of so omnipresent today with all of us in terms of the gadgets that we use, the laptops. So we are already seeing it, we are already using it, right? So we are going just one step further to say what is in it, right? And later we will explain in more detail through the entire program how to build such systems, how to design such systems, and so on. Okay. So with that background, we have designed this particular course of electronic systems thinking and circuits, right? Where we study and analyze various experiments and gadgets. Okay. For example, on this screen here, right, going from the top left, first row, I am dismantling a mobile, right? Then we are analyzing a battery, a charger, right? Then we are analyzing, in the third picture, you're seeing the analysis of a charger, right? Then we are looking at a kettle, right? What happens when you heat a kettle? Because that gives us some insight into what a resistance is, right? On the bottom row, left-hand side, we are looking at a microphone, right? That's the simplest sensing thing that we actually use on our phones every day, right? There's a microphone that senses our voice. It converts it to an electrical signal. What does it mean, right? What does that do? What does that time signal mean, right? And then we look at various kinds of filtering operations, and then we look at channel equalization and stuff like this, right? So one thing that I have to warn you, right, is we will be looking, right? We will be looking at a host of applications, okay? And like I told you, it's only a first order sneak peek into these applications, right? Now, therefore, you should not get overwhelmed by all these experiments. We don't expect at the end of this course that you will be able to perform these experiments and explain them perfectly. Okay, it's a motivation, right? The theory that is going to accompany this is something that you should be able to do. You should be able to solve problems around that. I'll come to the learning objectives in some time. Okay. So what is expected, right? While coming in, you should have a good background on calculus, integration and differentiation. Okay, that's what I mean by calculus. Okay. You must be familiar with electrostatic quantities like charge, field, voltage, and all that. You must have heard of it at least. Okay. We will still explain it in great detail. We don't assume that all of this has been covered in great detail in your school. That's not what we are assuming. But we are assuming you have heard of these quantities. Okay. And you should know magnetism, that if you have a current, you could have a magnetic field. Okay. These kind of things, we expect that you are aware, right? And of course, resistor, inductor, capacitor, all this you must have heard of. Okay. We are not expecting that you know how to solve circuit problems related to this straight away. Okay. Now, at the end of this course, some of the things that you can do is identify some ICs and electronic gadgets. Okay, if you open them, you should sort of, at least to a first order, try to explore. Okay, you should be able to perform basic network analysis on electric circuits, simplify resistor capacitor networks, perform time domain analysis on RC networks, and explain the idea of microprocessor memory, and explain the idea of a program stored in the memory. Last two things we will have to verify if we are able to do it or not. Okay. Now, like I mentioned, what are the learning objectives, right? Now, here I'm being very specific. Like I said, these demonstrations will cover a spectrum of applications. Okay. Now, this doesn't mean that you should know all of this and you should be able to explain every bit of it. Okay. What I mean here is, at the end of this course, as a student, right, what are you expected to do? That is what a learning objective means. Okay, so it's not sufficient. So just note that this is not called a teaching objective, where we are happy if we teach these concepts. No, we need to make sure that as students you are able to do these things. Okay, and what is it that you should be able to do? You should be able to apply KCL, Kirchhoff's current law, voltage law, to a circuit provided, and you should solve for unknown current and voltage. Right, you should be able to find the equivalent resistance of a resistive network. You should be able to solve the first order differential equation of a low pass or a high pass filter. You should be able to estimate the power and energy consumed due to time varying current profiles. Okay, you should be able to solve elementary switch capacitor circuit problems. You should be able to represent analog voltages as discrete integers and also represent them as binary numbers. So I'm being very specific here. That means whatever questions we set, whatever problems we solve will revolve around these concepts. Okay. For example, we will not be asking you how do you set up an experiment to measure the the charger, how fast the charger is charging. That's not what we expect from this course. Okay. We will give you a resistive network and say, what is the equivalent resistance of this network? those are the kind of problems that you will be looking at in your exams. And since this is the very first introduction to a circuits course, you must be familiar with this, because the next course will assume all of this for you to make quick progress. Okay. So essentially, there is electric circuits, there is electronic signal processing, there is digital systems. So this electronic systems thinking sort of looks to address an intersection of these three areas. Okay, but at a very first order level. Let me keep repeating that. Okay, the course spans 12 weeks and it is outlined as follows. Okay, now I think for those of you who already wrote the qualifier, right, you will see here that there's a slight change. Okay, so we started with understanding the battery, charger, energy and power. Then we looked at KCL and KVL. Then we said sinusoid and harmonics, right? And then in week 4, we said we earlier had planned to do the analog mixer. Okay, but based on some feedback and how we, on the performance of the qualifier exams, we thought we had to course correct a little bit and discuss some techniques of solving problems in circuits. That's why you see in week 4, we have now altered it. Instead of the analog mixer, which has been moved to week 5, we are looking at circuit analysis thinking and problem solving. So we, the faculty here discuss, just take a bunch of problems from simple to very complex, very simple to very complex. And we just discuss, okay, what is the kind of thinking? How do you start solving the problem? What are the checks and balances? How do you ensure your answer is correct? All these kind of things we discuss. Now, these are the intangibles of circuit analysis, but these are very necessary. And these usually are picked up only through problem solving. You have to solve a number of problems. Okay. So however, this introduction in week 4 is to just give you some hints. So every 4 weeks, we have such a discussion. Okay. Week 5, it will be the analog mixer, the RC step response, and then filtering. Okay. Again, all of this is based purely on what you have studied in your 12th standard syllabus. Okay. We have ensured that we don't assume any engineering background when we discuss these topics. Similarly, in week 8, there's a circuit analysis thinking and problem solving part 2, which will be slightly more complex problems that covers topics from week 5 to week 7, right? Week 9 is sort of, where we look at going into the digital world, okay, into a digital computer from the analog world. So you have to look at switch capacitor circuit analysis and the analog to digital converters. Then we look at digital representations, then basics of communication, and we'll wind up with some circuit analysis thinking and problem solving for a 3rd session. Okay, so this is how it has been planned. And the course components, you will have video lectures on the course contents posted every week, activity questions based on lectures to reinforce the concept learned, weekly practice and graded assignments. Okay, so these will sort of be very representative of the problems that you will encounter in your quizzes and exams. We strongly recommend that you independently and individually work out these assignments. You have to ensure it is for your own sort of reflection on whether you have understood a topic or not. Okay, we will also discuss the solutions and stuff. And Vasundhara, who is the instructor for this course, will have weekly live sessions to supplement the videos and solve tutorials. There'll be some lab sessions for hands-on experimenting. Okay, and of course there'll be a final assessment exam with a precursor mock test to gauge your understanding. Okay, so sort of I would say a high-level gyan that we should give, right? Make sure you use the opportunity to learn. It's not just about earning grades. You have to really reflect, okay, on how you solved a problem, why you solved it in a particular way, right? Why not in another way, right? These are the questions that you should ask. But for that, you have to listen to all the lectures attentively. You must take notes, okay? Writing it in your own words is what will help you retain it and understand it better. solve the assignment questions on your own. You can indeed, and it is recommended that you discuss with peers and instructors to get clarification on difficult topics, right? Don't hesitate to ask or say that you have not understood something. There is no shame in that. Okay, you should not hide your ignorance. Okay, please come forward and just say if you have not understood something. We will try our best. We will try to teach you in another way, maybe different examples. Okay, and be active in the discussion forum. Okay, there is a discussion forum. Post your queries, right? You can also respond to others, right? Your friends may ask a question that they may not know how to solve a problem. You are free to respond and say, look, here is how you do it, right? Or if the instructor or the faculty post one solution, you are welcome to please suggest an alternate solution or ask why the alternate solution is not okay, right? Again, attend live sessions regularly, make use of them for reinforced learning. It's just a word of caution. If you think you can catch up with live sessions later, it might be difficult. Please plan on attending live sessions when it happens. Don't depend on the recording. Okay. And yeah, go through the pertinent lecture videos before attending the follow-up interaction sessions. Right. Now, what are the reference textbooks? Yeah, William Head and Kimberly, engineering circuit analysis. Right. I believe there is a sort of an Indian edition available for this. Professor Anirudhan will talk more about that. Morris Mano, digital logic and computer design, and the art of electronics, right? But I would say we will limit ourselves primarily to the first two textbooks. Okay. So with that, I will stop my presentation. Okay. And I'll invite my colleague, Professor Anirudhan, to add any comments that he may have.
Thank you, Janaki Raman. I hope everyone is able to hear me. Is my voice clear?
Yes.
Yes, Professor.
Okay, excellent. So I think Professor Janaki Raman has covered kind of in a lot of detail about how this course is, what the contents are, how it's going to be delivered, etc. So I'll just kind of add maybe 2 or 3 very short points about the uniqueness of this course. So first thing, maybe I'll start from the highest level, which is from the point of view of the program. Remember that, and the first point is going to be reiterating what he already mentioned in his presentation. This BS in Electronic Systems program is obviously an industry-focused, job skills-focused program right from scratch. And because of that, you can see that unlike in a traditional system where you have theory first and followed by application, we are kind of, starting right with the application, right with a lot of applied points. The second thing is at the next level, which is the contents of the course. As you have seen from what he presented, this course, actually you will not find a course like this. I don't believe you'll find a course like this anywhere in the world as part of an electrical engineering curriculum, right? So this has obviously been thought up from scratch, and the contents of this course have been designed and created so that it is in keeping with the philosophy of the program and in line with the way in which we want to deliver the general technical knowledge that you should be exposed to during the course of your Bachelor of Science program, right? So this is kind of gives you a very high level overview, as you can see, of the overall electronic systems paradigm. And the third point I wanted to point out was the mode of delivery. Actually, some of you who have gone through the qualifiers will already know that we are actually trying to deliver the lectures in a slightly different manner from traditional courses. So we are trying to incorporate a more of a conversational style, and so we are trying as much as possible to have at least 2 professors sitting together and teaching you the technical content in a more I would say, in a more down-to-earth fashion, right? Not just in a traditional lecture format where we just keep droning on for, for an hour or two, but in a slightly more appealing way. So these are the three unique points that I wanted to point out. And, I'll now hand it over, back to Girish to move forward with today's orientation.
Thank you, Professor. So we have received some questions. Am I audible?
Yeah.
So we have received some questions through the G form. And we also have some students raising their hands. Maybe we can take both. So I request all students to ask questions only related to the course and not related to any admin or any admissions or any other general support related questions. So we will have a separate orientation for that. Before 20th of September, we will be having a separate orientation for the foundation level program level orientation. So, and you can ask questions related to the support at that time. So maybe you can take few questions, whoever have raised hands.
Absolutely.
Avi Gupta, you can unmute and ask your question.
Sir, I just want to ask that about the time duration of 12 weeks is for the full course of foundation level or just for the term one?
So the 12-week period is only for term one, not for the foundation level. So for the foundation
Okay,
level,
so it means that it is a half course.
sorry?
So it means that it is for the half foundation level, the instead of 12 weeks.
It's actually a little bit less than half. Okay. So you need to do the foundation level consists of 2 terms and 1 course in the 3rd term.
Okay, sir. Thank you.
Sumit? would
Hello,
you like
good
to-
evening. Good evening, sir.
Good evening.
Sir, can I pay extra fee for a lab kit?
So we will be having, that will be part of, we will answer this question as part of the overall orientation, right? This is related to only this EST course.
Okay, sir, one more question. It is like salary or package. Can I ask?
Okay, why don't you go ahead and ask, but we may not be able to answer it very well, but go ahead.
Sir, if I do this BS Electronics 4-year program very hard with all my efforts with hard work, so can I get package like 50-60 lakhs as a BTech student earn?
Okay, so of course, we are not able to answer this question very well, obviously, for 2 reasons. Number one, this is, as you know, this is a new program, right? What we can tell you is that, and this is a new program. And even if you look at existing, bachelor's programs, I'm not sure at the bachelor's level whether people earn 50-60 lakhs. I am not sure. I don't think so. Okay. Having said that, maybe I'll just point out that in general, as far as, the career option goes after this, I can assure you of 2 things. Number one, while building this course, we have actually had talks with, a variety of industry of various kinds, Indian companies, MNCs, large companies, small companies in various subfields of electronics. And they have all been very enthusiastic and very positive about this course. And many of them have also said that they will be open to supporting us through apprenticeships, as well as through, if the student performs well, they will be very happy to hire them. Okay, that is the only way I'm able to answer your question.
Okay, thank you, sir. Thank you.
Yeah, next, Venkata Subhash.
Yes. Hello, sir. Am I audible?
Yes.
Yeah. Very good evening, sir. So basically, I would like to ask a question regarding, I hope it was, I should not ask it here, but let me ask it and you decide it. So are we eligible to write GATE exam?
Okay, this is a good question and I will answer it. So what happens is GATE has 2 papers, TCE and three papers related to electrical engineering: ECE, EEE, and IN, instrumentation. Now, students who do this BS in electronic systems will undergo courses that will have maximum overlap with the ECE stream. So what you will have to do is you will have to take the right electives, because there are lots of areas of ECE that are not covered in this BS in electronic systems, because we are dealing only with electronic systems. For example, we are not dealing with the related areas in ECE such as communication or semiconductor devices and so on. But there are lots of areas that we do cover: control engineering, analog circuits, digital systems, and so on, right? So if you are interested in undergoing the GATE exam, what you will have to do is, in the 3rd and 4th years, you have a lot of flexibility to take elective courses in this BS program. So what you'll have to do is you will have to choose your electives very carefully, and then you will learn enough to write the GATE exam.
Yeah.
Does that answer your question?
Yeah. Actually, my question was this was I hope I was answered 50%. And like for GATE, are we eligible in terms of degree?
Yes.
Yes, you are.
Yes, that's not a problem. Yeah.
Yeah. One more thing. Is it mandatory to take some other BTech course?
What does that mean? While doing this course?
Yeah, along with this.
No, it's not mandatory. You can do this full time if you want.
Yeah. Thank you.
Alkesh Srivastava.
Good evening, sir.
Good evening.
Sir, now that the course outline has been updated, week 5 is now the analog signal, analog mixture, and week 4 is about problem solving on the circuit analysis. So,
Yeah.
sir, from which week we have to start the course?
Yeah, please look at the problem solving videos. Please look at it. If you have done the first 4 weeks and done analog mixer in as part of your qualifier, please do look at the circuit solving discussion in week 4 first. Okay, because like I said, that is something that we course corrected based on the performance in the qualifier exam. Okay, we gave certain questions, we saw how people performed, where people were struggling, and based on that we have decided to give this. So please take a look at that video, and then if you have seen the analog mixer, you can go to the next week after that. No problem.
Okay, sir. Thank you, sir.
Profs, we can take one.
Girish. Yes, Girish, before we go ahead, I just realized I forgot to add one point to the original presentation, which is related to the slide which is on the screen right now. So the first reference book, William Haight, Kemmerly, and Steve Durbin, it turns out there is a 9th edition of this book, for which there is an Indian edition. Okay, so you can use that as the reference for this course. Those of you who are interested, there is indeed an Indian edition. Professor Janakiraman, had mentioned at the end of his talk that I will cover it. I had forgotten it. I'm telling you now. Go ahead.
Thanks, Professor. We'll take some questions from the form that we asked in between. One question is, please advise on the prerequisite preparation for this course, especially for those who are returning to academics after long break.
So like we said, right, you must just know integration and differentiation. Literally, it is that. And you must have familiarity with, what an electric field is, capacitor is, and all that. Beyond that, we teach you everything from scratch. Okay, so if you're returning to academics, it means you have solved such problems earlier. Hopefully, when you start seeing our lectures, it will all strike and it should all fall back in place. But we will cover all of that from the basics.
Thank you, Professor. There's another question. This is related to lab. Is it absolutely necessary to attend the lab session? Partially, I will answer. Yes, it is important to attend the lab session. Professor, you can just elaborate a bit on the in-campus component.
Yeah. So first of all, I think I saw that question that was on the, and this person is from Coimbatore, right?
That's right. That's right.
Correct. So I think there's a misunderstanding that the person is assuming that he or she has to be in person in IIT Madras through the entire semester. I think that's not the case. Okay, you are supposed to come here only for a couple of days. Okay, once in winter and once in summer. Okay, couple of days is probably less than a week. Okay, so beyond that, the lab experiments and all, you will also be enabled and helped to complete it from home. Okay, so you have to come here because the lab evaluation will happen in person. However, your experiments need not be performed only on campus. You could perform it on campus. You know, if something is not working at home, you come here in 1 or 2 weeks, you finish everything. That's also a possibility. But you could potentially be here on campus only for 1 week in winter and 1 week in summer. And that's it.
Okay, thank you, Professor. There is another query. I think it looks like a mix of support query and course related query. Is this course similar to ECE, and are we going to learn signal systems and circuits? When they say course, I think they're asking about the entire program. So the question is the program similar to ECE, and are we going to learn signal systems and circuits in the foundation level?
Yes, I think I had covered that in the gate question. You will, you know, there is enough amount of overlap with ECE.
Correct. So we will be doing signals and systems, right?
That is indeed correct.
Yeah, correct.
Thank you.
So there is a specific course called Signals and Systems in this program that occurs in the third term.
Yeah.
Okay, we can take some more questions, those who have raised hands. Abhinav Bharadwaj, if you have already asked, maybe we can give to somebody else. Abhinav Bharadwaj.
Oh, sir. Good evening, sir. Am I audible?
Yeah.
Yes.
Good evening, Professor Aniruddhan, Professor Janaki Raman, and Vidish, sir. I really like the video background of Professor Aniruddhan. I had a question about whether we have some lab work in the E1101 this semester.
Yeah, I'll allow Professor Aniruddhan to answer that. Yeah.
Yes. So there is a small component. So there are two ways in which you will be looking at practical applications. One of them in this course is related to the circuits that you are seeing. So you will be seeing circuits related to resistors and capacitors and inductors and voltage sources and so on. So what we will teach you is, if you look at the credit split up, there is indeed a small practical component that is related to understanding more about these circuits via simulations. Okay, we will teach you how to simulate these circuits to get you used to simulators, because modern electronic systems, you know, often require a lot of simulations. Okay, there will also be a small lab component which will be dealt with when you come in person in December.
So we'll be using the
we could not hear.
Yeah, sorry, Abhinav, your voice is breaking. That is correct.
Am I audible right now? Hello.
Yeah,
am I audible
yes,
now?
you are. Yeah, yes, you are. Could you please repeat that last part?
Yeah, I was asking about that miniaturized signal generator and analyzer. Would we be using in this semester itself or from the next semester?
So what I will say is that when you come at the end of the term in December, you will already be using it. What we will do is we'll give you an orientation on specifically how to use that kit.
All right.
And we will also make you, you know, create and measure some very simple circuits, like the resistive circuits that you, you know, saw in class.
Yeah.
I see, sir. And I had one more question. Whether we would be allowed to have some sort of carryover, for example, due to some professional commitments or due to some collision. Maybe we cannot like attend practicals of one semester, for example, first or second or whatever. So could we have some carryover of that particular course lab work and then attend it in the next semester? I thought this is practically possible because we're having the 2 admission cycles in a year. So I thought.
Okay. So unfortunately, that's not easily possible. And I'll tell you why. So because for example, you consider what you're going to come, for in December. That will, you will be building and measuring some simple circuits, and that goes towards the credits that you will be earning in this term. Right? Because there is a practical component to this EST course. Right?
Yes,
so what happens is that this course, if you don't attend that, this course will be marked as an incomplete. And that unfortunately carries over. That is not, you should be finishing this because this course is a prerequisite for the next courses.
Yeah.
So like in case if one cannot attend the practicals, then one has to repeat the course, right? In the next.
Yes, but what we should do is you should remember that we'll actually give you over maybe a 2-week period. We'll give you 7. Like Professor Janakiraman mentioned, there are only this will only take maybe 3 days or 4 days, right? This lab session.
Yes,
so we will give you maybe 3 options, right, to attend the lab session.
I see.
So that it interferes as little as possible. You can choose the one that interferes as little as possible with your schedule.
Yeah,
I see, sir.
And this will also include a weekend and all that.
Yes, exactly.
Okay, yeah.
All right, sir. I see, sir. I also had quite a little feedback. I really like the innovative approach. I have also attended some NPTEL courses. The approach of having 2 TAs or 2 professors in a single video, it doesn't get so monotonous and it is quite interactive. However, at some places it gets a little bit like self-approving to the like TAs or the professors. I haven't seen this at many instances, but in some videos there was this kind of approval. I might quote it or maybe not, but for example, in the node selection and nodal analysis and so on, there was some sort of a double-sided approval that a student from a normal BTech course might not have, the questions were not very much cleared. So otherwise, this approach is very much innovative, and I think everyone would like this approach. But at some point, I think we would have to notify the professors and the team that, yeah, this concept is not very clear. And rest, I think that was very nice.
Okay, so what you're saying is in some cases, we should add even more detail than what we are adding. Is that the answer?
Yes,
am I understanding it correctly?
Yes, sir. Yes, sir.
Yeah,
sure.
So Abhinav, just one comment. Based on the qualifier performance, like I told you, we have done a course correction already, okay, about having a problem, sort of thinking on problem solutions, right?
Yes,
so
sir.
That is actually going to reinforce a lot of concepts that are taught in the theory. Okay, so
yes, sir.
That should actually clear out all the doubts that you have, right? So hopefully it should take care of your feedback. If not, please let us know.
That actually does it.
Sorry?
No, it was not that critical as such. Am I audible? Hello. I was saying it was not that critical as such. It was just a little bit like praise also, and a little bit feedback with that. It was not in some sort of
So this feedback is very important to us because it's the first time we are offering it, and we need the feedback. So if you think it is not serving the purpose, do let us know later on. Okay, once you see the new lectures. Okay.
Definitely, sir. Thanks a lot, sir. Thank you. Good night, sir.
Thank you.
Professor, there are some questions, some questions in the chat as well. I'll read out one related to course. This is from Namai. Good evening, sir. Since this course focuses on hands-on learning, will we also learn about microcontrollers like, I can't spell that. I think basically he's asking about the microcontrollers. Will we also learn?
Arduino.
Yeah.
Maybe Arduino?
Yes,
okay.
Correct.
So maybe I'll quickly take that question. You will be learning about such microcontrollers in a later course. So there are indeed, courses on areas related to this, such as embedded systems. And you will not be learning about that in this course, but later on in one of the future terms.
Yeah, thank you, Professor. Can take one more. Shivam Kumar Prasad.
Hello, am I audible, sir?
Yes, yes.
Yes.
Good evening very much, professors. First of all, I would like to appreciate and thank you all of you for bringing this excellent initiative from IIT Madras team and you all. So, Professor, my question is that this electronic system thinking and circuits part, Professor, is it similar to the electrical engineering part or is it different from it?
Maybe I don't understand. What do you understand by electrical engineering? Are you talking about electrical power engineering or something similar?
Yes, yes, sir.
Because what electronic systems, electronics is part of electrical engineering.
Oh, Professor, one thing more. Regarding the first question asked by Abhi Gupta, how many weeks is included in the term one course?
12 weeks.
Oh, so complete term one includes all the 12 weeks.
Yes.
Okay, okay. Thank you very much, professors. Complete team is summarized by the orientation session today. Thank you very much.
Thank you.
Thank you.
Okay, we have last a few minutes left. Maybe we can take few questions. Bhavesh Sharma, if you have already asked a question, maybe we can give some to someone else. Bhavesh.
No, sir. I want to ask.
Yeah.
Hi, sir. So I want to ask that I have interest in the semiconductors. Can this course give focus on that also?
Oh, no. This will not focus on semiconductors. This is a purely an introduction to circuits.
Okay.
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 Yeah. I mean, by the way, when you say course, are you talking about the electronic systems thinking or are you talking about the BS in electronic systems program?
Sir, in BS in electronic system program.
Okay. So that like Professor Anirudhan said, you will have sufficient options for electives that you can take at a later point. And there you can cover semiconductor device physics sufficiently.
Okay, thank you, sir.
Okay, yeah.
The next question is from Pratham. Will we learn or use prototype boards like Arduino? Sorry,
Yeah.
I can't spell that.
Yeah.
Or actual bare-bone micros and architecture like ARM Cortex and RISE.
Yeah. So essentially, will we learn the use prototype boards? So we will be learning, some typical boards, prototype boards. Okay. I forget the exact details and also some typical FPGAs. Okay. I think we are looking at the ESP, right? Anirudhan, is that right? We were looking at, I think
that is correct.
Right?
That is correct.
ESP microcontroller and stuff like that. So you will be learning some prototype boards. Yes.
Okay. Thank you, Professor. There's another question which we got from the form.
Yeah.
This is more at a level not particular to this course. Will I be able to develop a product after foundation level course?
Okay, maybe I'll take this question. So I think it may be a little bit impractical for you to imagine making a wide variety of products. Having said that, in the foundation courses, you will learn fairly applied knowledge of, several different areas. So for example, things like on the analog electronic side, indeed, you will be looking at, a couple of courses, and even on the digital side and the programming side. But having said, you will see that, you'll probably be able to just start, appreciating each one of these areas. What might be better is for you to wait till the diploma is over, because you do see more very advanced applications. On the analog side, for example, you have sensors and sensor systems. On the digital side, you'll hit FPGAs, digital system design, and so on. Okay, so I think you will have to wait till the diploma before you get a very applied knowledge of these areas.
Thank you, Professor. I think it's almost time. Maybe you can give some concluding comments and some remarks before we end the session.
Okay, so thank you, Girish, for arranging this, and thanks to Vasundhara for sort of interacting with the students and being the lead instructor here. The only sort of the advice that I would give the students, right, is please solve as many problems as you can. The only way to learn circuits is familiarity through solving numerous examples. Okay. So we have suggested a textbook. There are worked out examples in that. There are problems given at the back of the textbook. Please sit down and solve them. Also, we will teach you different kinds of techniques to solve the same problem. Please solve every problem in as many different ways as you can, because that's the only way you can check your answers. Okay, in the exam, when you have no other help, right, what do? You only can check it through different ways, and we will teach you, how to actually try and check these answers, verify if they're correct and all that, right? So please do all of this diligently, put in a lot of hard work, and I'm sure you will enjoy this course. So, Ani, any concluding remarks?
Yeah, thanks, Janakiraman. Just a couple of points. I would say, number one, to reinforce what Professor Janakiraman said now and earlier as well, I think it is very helpful. It will be very helpful if you have a notebook where you write down these notes. I think Professor Janakiraman mentioned during his talk as well, because just the act of writing kind of internalizes a lot of information, a lot of understanding into your mind. So I think that part is very important. And number two, what I would strongly suggest is, don't miss out on submitting the weekly assignments and quizzes and writing all quizzes, because the weekly assignments will actually give you a lot of knowledge and practice that will help you in your quizzes, right? And in your end semester examination. So don't neglect your weekly assignments. That's extremely important. And finally, good luck to all of you for a great term.
Thank you, Professor. Thank you, Professor Janakiraman and Professor Aniruddhan, and also thanks to Vasundhara for arranging everything. So I see a lot of questions related to the support or related to administration and related to admissions and so on. So I request all of you to ask your questions through email to our support team. You can send us a mail support-es@study.iitm.ac.in. And also we will be having a orientation at a program level, that is for the foundation level. Before 20th of September, we will be having, you can ask all your questions at that time. This was more about the course itself, hence we restricted to only course level questions. Thanks once again, professors, and thanks all the participants for joining this session, and have a good night.
Thank you, sir.
Thank you very much, Professor.
Good night.
Good night, everyone.
Good night,
Thank you,
sir.
sir.
Thank you.
Thank you,
Good
sir.
night, sir.
Thank you, sir.
Thank you, Professor.
Good night, sir. Thank you, sir.
Thank you, all the professors.